Hello, in this video I'm going to show you an example of DIVEX and Composition Language 1 where the types and functions are defined in F#, and the code I have written here is based on code from the site fsharp4funandprofit.com from an article series about dependency injection. So in this example I'm going to show you how we can do dependency injection with F# and Composition Language 1. So this example is about comparing two strings, right? So we ask the user to provide two strings, we compare them, and then we print the result to the console. Okay, so here I have a discriminated union, which is the result of comparison. So the result of comparison will be that the first string is bigger than the second, or it's smaller, or they are equal, right? Okay, so here I have a function ask user for strings, and here we are declaring the dependencies of this function, right? We are saying we want a function parameter that we can use to read a line from the console, and then a function parameter to write a line to the console. And here we are using this writeLine function to enter the first value into the console, and then we are using the readLine function to read one string from the console. We are then asking the user to enter the second value, and then we are reading the second value, right? And then we return the first string and the second string as a tuple, right? Okay, so if we look at the signature of this function, the readLine function, it doesn't really return a string, but a generic type, right? Now the writeLine parameter, it takes a string, right? So F# has a tendency to do this. So like if you create a function where you don't put restrictions on some value, F# by default treats this value as generic, right? Okay, so this function, the compare two strings function, it takes two strings, but again here they are generic types, and a log function, right? And then it compares the strings, and depending on the result it returns bigger, smaller, or equal, right? And here we are using the log parameter to log certain things about this function, right? Like the fact that we are starting, the fact that we are finished, and then the result, right? Okay, and here we are returning the result. Okay, so this writeResult function, it takes the result and a function to use to write a line to the console or any other place actually, and then depending on the result it either prints the first value is bigger, or the first value is smaller, or the values are equal, right? And this function returns nothing. Okay, so this program function is supposed to use these first three functions, right? But here it doesn't depend directly on them. So the program function doesn't have any dependency on any of the three defined functions here, right? It takes function parameters, and these function parameters have a signature that is convenient for the program function, right? So for example, if you look at the readStrings function, it takes unit, meaning it takes nothing, and it returns a tuple of two elements, right? The compare parameter here, it's a function that takes two values a and b, and it returns c, which is a third value, right? It's not even specific to comparing strings, right? And the writeResult parameter, it takes the result of comparison regardless of its type, and it does something with it. It even returns d. Now in our example, d will be unit, right? Because after we write something to the console or wherever, we don't want to return anything. Okay, so I could like return unit here, and this would cause F# to infer that writeResult returns unit, but I want to keep this open. And if I do, program would return whatever writeResult returns, right? Because functions in F#, they return whatever the last expression evaluates to, right? Okay, now let me show you how we can compose those functions in Composition Language 1. So here I have a C# project that references the F# project, right? And the C# project of course has to reference divex.core and divex.core.f#. And here I have a file called program.cscompose, and this is of course composition language 1. And here, for this to work, the DIVEX Visual Studio extension needs to be installed, and the build action for this file has to be C# analyzer additional file or additional files, right? And this file here, by the way, is generated code, so you don't need to change anything here. Okay, so back to program.cscompose. Here I'm using the using static feature of C# to use all the functions in our F# module, right? So here I'm referencing the program function inside F# module, and I can simply here use it directly without specifying the name of the module, right? And if I hover over the program function here, I can see its signature here, right? So it has a read strings parameter, a compare parameter, and a write result parameter, right? And here what I'm doing, I'm injecting the ask user for strings function as the read strings parameter of the program function, right? And here the ask user for strings function, it takes a read line function and a write line function parameters, right? And the read strings parameter of program, it doesn't have these parameters, right? So the signature of ask user for strings, it doesn't match the read strings parameter, right? But DIVEX allows for this, and these parameters will bubble up to the resulting function. And therefore this resulting function here, if we look at the signature of it by putting the mouse over the opening square bracket here, these read line and write line parameters were bubbled up from ask user for strings, right? And what does this mean? It means that I have decided on the fact that I want to use this function, the ask user for strings function, as a way to read strings, right? But I kept the decision of the values to use for read line and write line undecided. I have basically delayed such decision, right? Okay, now here I'm injecting the compare to strings function as a value for the compare parameter of the program function, right? And the compare to strings function, it takes two values, setter1 and setter2, and a log function, right? But the compare parameter of program, it doesn't take a log parameter, right? It only takes two values and that's it, right? But again, DIVEX allows for this, and it bubbles up the extra parameter or the extra parameters to the resulting function, right? So here, this function here, it takes this log parameter which was bubbled up from compare to strings, right? So again, I was able to decide that I want to use the compare to strings function for string comparison, but I kept the decision of what log function to use undecided, right? Okay, and here I'm injecting the write result function as a value for the write result parameter of program, and again this function has an extra parameter which is write line, and this is bubbled up to the resulting function, right? So this resulting function, I can view its signature by putting the mouse over the open square bracket syntax here, and it takes a read line function which is originally a parameter of the ask user for strings function, a write line function which also comes from ask user for strings, a log function which comes from compare to strings, and another write line parameter coming from the write result function, right? And functions in DIVEX are allowed to have parameters of the same name, right? And we usually deal with this in two ways. In the first case, we want those parameters to be merged. That is, we want the consumer to supply a single value, and we want this single value to go to the two destinations, right? So in this case, I'm using the join operator to join all parameters of the same name. So if I look at the signature of the resulting function here, it only has a single write line parameter, and whatever value I supply for this parameter, it will go to both parameters, meaning it will go to the write line parameter of ask user for strings and the write line parameter of write result, right? Now the second way to deal with parameters of the same name is to say that we want the consumer to vary them independently, right? And to do that, we need to rename the parameters before they come part of a single function. And let me show you what I mean. So I can come here and say I want to rename the writeLine parameter to be writeLine ask, let's say, right? Okay. So here I'm renaming writeLine to be writeLine ask, right? And here I can rename the writeLine parameter of writeResult to writeLine result, right? So in this case I wouldn't need the join operator, and if I look at the signature of the resulting function, it takes two writeLine parameters. One is called writeLine ask and the other is called writeLine result, and this way we allow the consumer to vary these parameters independently, right? But this is not what I want to do in this example. Okay, so now we have a function called program potentially pure that takes a readLine parameter, a writeLine parameter, and a log parameter. And the reason I call this function potentially pure is because it can be pure or impure depending on the values I supply for these three parameters. If I provide pure functions here for readLine, writeLine, and log, then the function will become pure. But if I provide impure values or impure functions for these parameters, then the function becomes impure, right? So a potentially pure function is a function that has a pure body, but that takes parameters of type functions and calls those parameters, and depending on the values passed for these parameters, the function may become pure or impure. Okay, so here I'm using the program potentially pure function to create a version of the program that reads from the console and writes to the console, right? So here for readLine, I'm using console.readLine. For writeLine, I'm using console.writeLine. And for log, I'm using console.writeLine with a log prefix. But I could also, for example, write to the file system, right? So now we have a function that takes unit and returns unit, right? And this is an impure function, right? Because it uses the console, right? And if I run this example, it's asking for the first value, let's say car, the second value, let's say book, and then it's logging here the fact that it started comparing, and here the result, and here the fact that we finished comparing, and then here the last line. This is from the writeResult function, right? Okay. So basically what I can do, I can create many potentially pure functions that declare any dependency that would make them impure as parameters, right? And then I can compose those potentially pure functions into one potentially pure function that represents the whole application. And then I will have a version of that function that is impure by supplying dependencies that are impure. For example, real functions that talk to the database or the file system or the system timer. But then in a test, I can use this function here and pass mocks as values, right? And because this is a potentially pure function, I will know as I am writing the tests that the only way this function talks to the outside world is via these functions, right? So if I mock these functions, I know for sure that the system under test is not going to use the database or the file system or whatever, and the only things I need to mock are these parameters here, right? And the nice thing here is that if a low-level function declares a dependency, we don't have to pass this dependency manually from high-level functions to the low-level function, right? So for example, the program function, it doesn't take the writeLine or the readLine functions as parameters, right? So only low-level functions like ask user for strings has the readLine parameter and the writeLine parameter, right? And by using the concept of bubbling up parameters, we were able to bubble up these dependencies into the high-level function, which is the program function, right? So in this video I have talked about dependency injection and how DIVEX can help you create potentially pure functions and compose them to create a larger potentially pure function and delay the injection of impure dependencies to the last possible moment. So if you would like to learn more about DIVEX and Composition Language 1, please subscribe to this channel, and if you like this video, please hit the like button. Okay, thank you for watching.